Since ancient time, tin or its Latin name, stanum, is already discovered and classed as other metal and non-metal. The color of tin is silvery white, and it is known that tin was discovered at the Bronze Age that began around 3000 BC because bronze contained 90% copper and 10% tin.
The objective is to understand the general properties and trends within group 14 by tin and to acknowledge the importance and usefulness of the periodic table.
Tin is an element that belongs in the carbon family, which is group 14. It appears to be a soft, silvery white metal that has a bluish tinge. Tin also has a low melting point and a low boiling point. For the chemical properties, tin can react with strong bases and strong acid, but does not have reaction with neutral solution. It doesn't oxidize easily and able to resist corrosion due to its oxide film that is protecting it.
When tin atom bonds with chlorine atom, it will form a covalent compound of tin for chloride. Tin atom has 4 valence electrons while chlorine atom has 7 valence electrons. So in order to achieve octet rule, tin atom shares 1 electron from each 4 chlorine atoms while chlorine atom shares 1 electron from 1 tin atom. Another example of covalent bond that tin can form is tin fluoride and tin chloride. Next, tin atom can also form an ionic bond with other elements. When tin atom is bonded with a non-metal group element such as oxygen, it will form an ionic compound. To achieve the octet rule, tin with a valence electron of 4 will donate 2 electrons to each 2 oxygen atoms, while 2 oxygen atoms receive 2 electrons from tin atom. Hence, an ionic compound of tin 4 oxide, SnO2, is formed.
The electron configuration of tin expressed by using SPDF notation or using a noble gas core with the application of Aufbau principle, where the electron enters the orbital in order of ascending energy. Tin electron configuration by using noble gas represented with Kr or krypton 5s2 4d10 5p2, Sn2 plus represented with Kr 5s2 4d10, and Sn4 plus represented with Kr 4d10. By using orbital diagram, electron represented with arrows in the box. In this way, the Hans rule apply where the orbital of the same energy must be occupied singly and with the same spin before pairing up of electrons occurs. And the Pauli exclusion principle also apply where the electrons occupying the same orbital must have opposite spins.
There are several types of structure for stanum. Firstly is crystal structure. There are 2, alpha tin and also beta tin. The next one is atomic structure. Stanum has 50 electrons bind to the nucleus, successively occupying electron shells that are accessible. The next one is Lewis structure. Lewis structure for stanum, it has 4 valence electrons in its Lewis structure. And the last one is molecular geometry structure for tin chloride. The shape is in V shape or band due to one lone pair.
Atomic spectra is a series of colored light with dark space in between that is used to observe the emitted light. The emitted light is the light of certain wavelengths with different colors that produce when atoms are excited. Since each element produces a unique spectral light, elements can be identified based on their atomic spectra. Same with other elements. Sn also has its specific atomic spectra as shown in the figure 7. The dark lines in the absorption correspond to the frequency of light that was absorbed by the tin.
Hybrid orbitals are the product of a model that combines atomic orbitals on a single atom in ways that lead to a new set of orbitals with geometries that are suitable for the VSEPR model to form bonds in the direction expected. Geometries that are very similar to the seen in actual molecules are predicted by the VSEPR model. The Lewis structure of tin 2 chloride that we are seeing right now, there are 2 number of sigma bonds and 1 number of lone pairs that occur between 1 atom of tin and 2 atoms of chlorine. From here, we can predict the hybrid orbitals for tin 2 chloride is sp2. This prediction is proven based on the figure you are seeing right now. According to VSEPR theory, the shape of essential 2 is V-shape or band due to one lone pair. The presence of electrons pair in the center lead to the repulsion between electrons.
In a nutshell, tin is a soft silvery white metal that has a bluish tinge. It belongs in the carbon family and mainly has metallic properties. It also has 2 allotropes, alpha and beta, that can change between higher and lower temperature. Tin mostly can be found as a beta tin, which is used in alloys often for its properties. Tin has 4 valence electrons, therefore to represent it, tin has 4 dots around it based on its electron configuration.